Welcome back, engineers. We are moving into the concept of numbers now. There are several different numbers when it comes to system design, like latency, throughput, bandwidth, availability, storage, etc. We're going to cover all these topics in this numbers section, and we are also going to see how we can do back of the envelope estimation to estimate large scale systems, right? I hope you're ready. Let's get started. We're going to start with latency. So we'll start with the question, what is latency? So as you can see, the definition for latency is the measure of delay, the time to get a response to a request. So when some request is made, there is some response we are getting back. The time difference between the request time and the response time is latency. So let's take an example to understand this. So let's say this is a lazy Friday evening and I'm ordering pizza, right? And I've placed the order at 9:30 p.m. So the order has gone to the pizza place, something called Awesome Pizza. They are preparing it and the pizza is ready by 9:50 p.m. right? So there is a total time gap of 20 minutes here. And then the pickup guy has arrived 5 minutes late and the pizza was picked up at 9:55 p.m. And the driver drives along the way and delivers it to my home at 10:10 p.m. So the overall time difference between the request time and the response time is around 40 minutes in this case. So 40 minutes is my latency for this request. Right? So 40 minutes is the latency. So let's try to understand what are the factors contributed to this latency. So firstly, order is placed at 9:30 p.m. and let's say there is no delay in this transaction. So the order got directly placed with the pizza place and there are no network delays or anything here, right? So here there is some delay because we need to process the pizza or actually make the pizza, right? So this is the process time. And once the process time is there, we are waiting for the delivery guy to come. So this is the waiting period. And once the waiting period is done, this is the drive time, the actual distance between the pizza place and the home location, right? So there are different factors contributing to latency. First is the network delays, if there are any. Otherwise, the processing time by the server, in this case the pizza place who's actually making the pizza. And then there could be some waiting time, it could be because of some queue. And the final physical distance between the pizza place and the home delivery, right, which is actually drive time. So all these things contribute towards latency. Next, I would like to show you the latency numbers every programmer should know. So these are numbers I took directly from the book System Design Interview by Alex Zhu. And let's try to understand these with some examples, right? So this is mainly a chart about the different latency numbers for different operations when it comes to the computing world. So let's say there is an L1 cache reference which is having an average latency of 0.5 nanoseconds, right? So similarly, there are numbers given for other metrics as well. Let's try to understand these with some examples. So let's say we are in the nanosecond world. Nanosecond is for 10 to the power negative 9 seconds, right? And L1 cache, this is the closest to the CPU. It's like whispering something to your neighbor who's sitting right next to you, right? It does not take much effort to send the information to the next person, right? That's why it is less than a single nanosecond. It is approximately 0.5 nanoseconds, right? Now, when it comes to L2 cache, which is slightly farther away from L1, we're still in the same room. Let's say I'm stepping out from this chair to pick a book from a bookshelf, right? So we are still in the same room. The average latency is 7 nanoseconds for me to get up, go to the bookshelf, pick up the book and come back to this spot, right? So this is L2 cache. We are still in nanosecond world, remember? And the third one is main memory, RAM. So now we are moving away from the room. Let's say I'm in my study room. I'm moving away from the study room to go to the kitchen to get my coffee. Let's say this is our RAM. So this distance, this latency is around 100 nanoseconds. So we are still in the same computer, but we are moving away from the CPU room to the RAM room, getting something from there. And because of this, we are getting 100 nanoseconds. So as you can already see, with distance, the latency increases, right? Now let's go into the microsecond world. Let's say we want to send 2 kilobytes of data over 2 Gbps network. And the metric says that in order to send 2 KB over 2 Gbps network, we are getting a latency of around 20 microseconds. So how did we get this number? Let's see. So 1 kilobyte is 1024 bytes. 2 kilobytes is double of that, 2048 bytes. And if we convert it to bits, we get 16,384 bits, right? And let's say we are having a Gbps network, that is 10 to the power of 9 bits can be transmitted per second on this network, right? So what is the time to send 2 kilobytes? So we need to send 16,384 bits over 10 to the power of 9 bits per second, which is coming to around 16.384 microseconds, which is rounded off to around 20 microseconds. So this is how we can send 2 KB data over 2 Gbps network. So depending on the bits as well, the latency changes. Now let's see the round trip within same data center. So we are moving from tower A to tower B and coming back. So this is a round trip. For a round trip like this, we are getting 500 microseconds as the latency. Now we'll move into the millisecond world, which is 10 to the power negative 3 seconds. So let's say we are looking at a disk seek situation. So let's say I want to read some data from a disk, and in order to read some data, first I need to know where the data is located in the disk. There could be several different tracks in a disk, and we need to identify the disk seek. So this is like finding the right runway at the airport. If there are multiple runways, I need to know which runway to enter in order to actually take the passengers to the safety. So this checking of the runway is taking about 10 milliseconds of latency. Now let's say I am there and I know where to look for this data now. And to actually read the data, I am reading, let's say, 1 megabyte of data from the disk, and this is coming to around 30 milliseconds of latency. Right? So we've moved from nanoseconds to microseconds to milliseconds. Now let's have a look at the last thing, which is sending a packet from California to Netherlands and then back to California. So this is like a round trip around the entire world, and this is coming to be around 150 milliseconds. So this is where the actual term called lag is what we can notice in the response, right? So these are some of the key numbers that every developer should know when it comes to latency, right? So if you want to learn more about them, just check out latency numbers on Google. You will find a lot of information on these numbers. Now finally, let's look at how to improve latency. So like we discussed, we need to take care of a couple of things. One thing is reduce the physical distance. That will naturally reduce the latency. And the other thing is reduce the processing time so that latency is improved as well. So some of the techniques are like this. First, let's say we can use a caching mechanism. So this could be a RAM or CDN, depending on where we are using. So if it is within the same computer, try to get stuff from the RAM as often as possible, because as we have seen, RAM is in the nanosecond range while disk is in the millisecond range, right? And let's say we have a CDN. So this is acting like the closest server to fetch static assets from around the world. So we can use this when we are talking about distributed systems and static assets, right? And you can move the servers closer. So if you're on a cloud environment, you can choose the region where you want to put the server. So pick a server or pick a region that is closest to you or closest to the user, let's say, and that will bring down the latency to a great extent. And the third way to do it is to use async processing. So don't keep the user waiting. So just acknowledge that the request is received, and don't keep the user waiting. We'll keep on updating through some other mechanism, and this request latency can be naturally dropped, right? So these are some of the ways to improve latency. So that's all I had for this video, guys. This is all we need to know about latency. Thank you so much for watching. Please leave a like if you found this helpful. Please subscribe if you haven't done already so that you don't miss out on any videos. Thank you so much for watching. I will see you in the next one. Cheers.